Howdy y'all, I'm Joe Hughes, and this is a session entitled DevOps 101 for the VI admin. This is going to be a little bit of code, Git, CI/CD, and infrastructure as code for us as vSphere administrators. There's a bit.ly link here at the bottom, bit.ly/vmugdevops101. So if anybody wants to get a hold of this code to actually see it while we're going through this in this session or for later on, please feel free to grab this link. Again, howdy y'all. I'm Joe Hughes. I'm here because I'm a VMUG leader, and honestly, I just love to get people engaged in learning, and I want to get people to be involved in the V community and hopefully get some things out of these presentations and give back. You can find me online on Twitter. I will be at jhughes. Since nobody can ever spell my last name correctly, you can also find me at fullstackgeek.net. And again, go to bit.ly/vmugdevops101 for this code or to get a hold of this for later. All right, getting started with the actual presentation itself. So, how do I do DevOps, right? We want to understand that this is really an IT management philosophy. For us, especially in the vSphere space, right? This is going to be a methodology of full stack engineering. We're just going to be focused on the infrastructure half of the stack, right? So really, at this slide, I want to make sure that we're starting here to understand what it is that we're getting into, especially for vSphere admins. We want to level set some expectations, right? This whole presentation, this whole session is going to be basic concepts and discussing some things from a new perspective so that hopefully we will understand a little bit better. Will this session make anyone an expert? Absolutely not. But it should help you to think about things a little bit differently and see some basics in action, and it will give you another step in your learning journey, right? So DevOps in my organization. What if we don't do software development? Most of this session should still be applicable if you're not working in a software development shop and shipping your own code, because we're not taking ops and operations out of the loop here, right? We're just making it more automated. That's really what we're trying to get to here. What do we get, right? DevOps really works to create certain specific outcomes, so it's only useful when you want those outcomes, right? Does everybody need to do DevOps now? No, absolutely not. If you don't like what DevOps will bring to you, again, if you don't want those outcomes, then don't do DevOps, right? I really kind of hate saying some of these things because it's, again, a methodology, not really an action. It's not, a job title. It's not a specific role that we're fulfilling in our org for this. This is about changing mindsets and doing things in a different fashion. But what's the point of all of this, right? Really, I want everybody to think about how you're making changes to your environment, how you're testing those changes, and how you'll be able to undo that change to your environment. This is all about enabling rapid deployment of software, right? When that software breaks, DevOps is meant specifically to equally support rapid deployment of a replacement version or the last known good version, right? Either roll forward to something that works or roll back to what worked before. Even if you're not going to fully automate software and infrastructure deployment pipelines, you should be aware of what these capabilities are when it comes to automating your environment. So start with the plan, right? Heads up, here's my usual speech to user groups, since it's not just relevant for code. This is going to be the same whether you're using the GUI or the CLI or automated pipelines, right? Plan for success always. But define your success at the beginning, right? Define a goal and think in tasks, in terms of tasks and measurable results, right? Expect difficulties or failures, be prepared to adjust this plan, but still plan for success. And as part of the plan, you've got to define it well and be explicit with facts, assumptions, minimum requirements, right? Speed and performance, right? Speed and performance are great, but they're an advantage to the organization. They're not the true benefit of automation, right? Think about the real benefit to the business here, which is accuracy and repeatability. It's not about impressing somebody with your code. It's not just about doing it fast, but it's about doing it correctly and being certain that it stays that way over time, right? Whatever you've defined you want your environment to look like. Standardization, validation, and efficiencies, right? The goal of all these efforts is not just about getting operations into code, but it's these actual benefits you can get from it, right? It's standardizing things, the way you deploy things, the way that you carry even code across different environments, right? Granular control, and then validation of your configurations, right? And then testing that you've actually achieved that success that you know what you're aiming for. And then small and incremental changes, right? Things that can be verified, right? MVP here is minimum viable product, right? We need to build and maintain tools in this fashion, and now the tools are going to be mirroring our internal environment and operations, right? But making these small incremental changes means that it's easier to improve or even completely rewrite these things as we change platforms or technologies, which is really what matters in the long term. So again, just try to be specific about your steps and components and have an expectation before you start. Don't do more than is necessary to make those minor changes, and then that way you can track those changes and the results of them afterwards. then make additional changes as necessary, but that way you're testing and verifying things along the way, right? That's a lot of what we're trying to do with DevOps, right? Is actually have measurability for a lot of these things. We want to actually be able to capture what is good and what is bad, and how well are we achieving our goals, even how quickly are we doing them, or possibly being able to roll back. If we understand all of these concepts and work with the organizations that we are members of to help them operate in this fashion, it enables us as vSphere admins, right, to be more valuable to the organization, because now we're enablers of the business and they can more easily trust our capabilities because we can show them what we're doing along the way. Don't fear the changes as your company's needs grow. And we always have the ability to continue to provide value to the business then, which is going to lead to great things in your career. So quickly, one thing I want to mention before we get into some Power CLI stuff. So don't forget the Powershell Basics. First of all, follow the PowerShell way even when you're building your own tool. Remember what we learned of these basics. Look at the help files, right? Get help as your friend and it makes your life easier. If you're stuck or need more help, check out examples, check out online documentation, right? Other people are also normally glad to save you some pain in your journey. PowerShell, it's built for the pipeline, so embrace and use it, right? This is going to be kind of our first entry into doing automated deployment pipelines and things like this, right? You take one object, you get some information about it, maybe you feed it to something else to modify it, maybe you get a report out of it, or maybe you do additional things and put it back somewhere else, right? The pipeline concept is very simple. First, get an object and then work with it. That's it, right? At the very basic level, that's what we're doing with all of these things. Once you learn how to leverage the pipeline and connect commandlets together, you can see how quickly you can achieve massive results with PowerShell. This is going to extend to anything else that we're doing in infrastructure as code. Once you know how to work with a specific object and how to modify it, and maybe how to get information from that to do something else, that's going to give you just absolutely amazing power within your environment to do some of these things. Stacking commandlets and results like Lego, right? Seriously, get some Legos to practice. Buy yourself a set if you're outdated on this concept. First of all, I always joke and tell everybody, if you've ever been able to figure out how to properly expense these as a business write-off, please let me know. I would love to hear that from one of these presentations, and to use it myself as well. But the new sets that exist with Lego can be a very complex final product, and there's going to be many distinct steps that get you to that final result. But this is why you should have an expected result at the start, because what you're going to get is what shows up on the box, but you may not realize there's pieces, that are small, multiples that are put together in interesting ways, different colors you never see on the outside of it, right? But you have that expected result from the start, and then you follow through specific steps to achieve that result. You may not ever see those things unless you're the one putting this together or pulling it apart because there's a problem with it. But you want to have that expected result that you know that you're working towards in the end. Forget what your teachers told you. Cheat and look up the answer whenever possible, right? So believe it or not, you can cheat from yourself. In the PowerShell and Power CLI world, if you're trying to learn the code or find a specific setting, just create something new or change things in the GUI and then pull it up in PowerShell to see how it was done, right? Just get to the answer. That's really what you're trying to do here. The path to get there doesn't matter to the business as long as you can achieve success, right? If you found the answer on Stack Overflow, or if you spent 8 hours figuring it out yourself, the business is going to be happier if you found that answer quickly, rather than having to go through a lot of re-education or stumbling through to find the answer yourself. It's going to be good for you in your own education to learn how to do it, but sometimes it's more important to the business to just get to the goal, right? But at the same time, you have to be careful, right? You don't want to rely too much on searching, since searching is not necessarily the same thing as learning. But you can teach all of these things to yourself if you put in a little bit of effort, and you can always ask people if you get stuck, right? Just focus on the result, because it's only important that you attain the goal or the desired result. If you learn things along the way, all the better for you and your career. With that, we will go ahead and jump into some demos for Power CLI. Okay, y'all, we're here for our quick intro to Power CLI. This is going to be super basic stuff, but again, if you haven't seen it or don't understand some of these basic concepts, maybe it's going to be something that'll be beneficial for you. First, we're going to start by connecting to our vCenter server. I have credentials that are already stored in this box, so it just automatically connects for me. If you do not have credentials stored, it would prompt you for your credentials to get into your vCenter box. I'm going to start with taking a look at my data center, right? I have a single data center titled Austin. I want to look at my clusters, and I can see that I've got 3 clusters, one for home media, one for my physical servers, one for management cluster. And then I'm going to look at my hosts, right? I've got one in maintenance mode, but I can see the others are connected. I know what power state they're in. I know how many CPUs they've got, things like this. And then I want to do something where I want to pipe a command together, right? This means I'm taking input from one command, output from the first command, piping it into the input of the second command. And I just know logically I can get a cluster and then I can get a host, right? Because beneath the clusters are the ESXi hosts. So logically, those two would kind of connect together. But if I want to know how I could find that information and how I could figure out what I can link together, I would leverage git member, right? So if I take this command that I've got here, if I can get this thing copied, and run it on the left, I will run a git member for my cluster, right? So underneath my cluster, what I'm getting back is this implementation of a cluster, right? It's this huge, long type name. But all I need to do is take this type name, right? And I'm going to feed this in as the input for Git Dash Command. So I'm going to say Git Dash Command, and my parameter type of what I have, right? This object that I have that I'm working with is going to be this cluster implementation. So if I run this at the command line, I can see what I can take my cluster and what I can pipe it into, right? So I can see that I can pipe it into Git Dash VM host. I can also get VM, right? I can get my virtual network. I can get basically everything that lives underneath the cluster level, because all of these have a parameter that accepts input from this cluster object, right? Mostly just from it being this VI core implementation inventory object, right? It knows, these commandlets know what to do with VI inventory objects. So if I want to get my VMs, let's clear this out and let's see, what are all the VMs that I have inside of my environment, right? And this is everything just sorted by name, right? This is what I've got inside of this lab environment here. If I want to get a specific VM, this WinDev box that I'm working on right now, I want to look at all the properties that I have for it, right? It's a Windows dev box. It's powered on. I get the UUID. I get how many CPUs, how much memory, things like that. I can get some information about the guest. Some of this stuff gets a little bit gnarly, right? But I also want to know what else actually exists here. So what I want to do is pipe this to another commandlet that I have installed in this box that's called show-object. This comes from the PowerShell cookbook module on the PS Gallery, so you can find this to use it. But basically, this gives me a tree view where I can look at a lot of information that's inside of here. So, information for the VMware hardware versions, extension data was what I was trying to get to down here at the bottom. This extension data is essentially going to be a match for like the API view of a VM, right? So everything is here and it's in these logical buckets or containers, where everything from here just kind of goes in this tree view to be able to see all of these objects and how they're associated, right? Everything under the network is going to live here under a particular NIC and then distributed port group and things like that, right? So easy way to get in and dig pretty deep for what's going to be the API view of a lot of these things. But let's say I want to know, what exactly I can do with this commandlet itself, right? So I run git help for git-vm, I can pipe in, or I can give it the name of a particular VM, right? A string that's in here. I can give it a data store. I can give it a location being a folder. I can tell it what server to start with. I can look for tags, right? And it will just find all of these things based off of these pieces of information that I have. The other thing I can do is I can work with a variable, right? I want to get my VM object and I want to put it in this variable. Now I can say I want to run a calculated property, right? This just means like give me back some custom information and some labels, right? Or I can just run select object and pick particular properties that I want to see back. Here I'm telling it I want the name, I want CPU, memory information, how much used disk space, what's the guest info, what's the guest ID, right? Some of this information where from here, that's great, but I want to see it in a different format. So I'm going to pipe it to format table. This will give me the same information just in a table format. Unfortunately, this console right here is a little bit not wide enough to be able to see that properly, right? If I do this way, you can actually see all of this information come back in a table format as opposed to a list format. But now, again, since I have this thing in a variable, I can work with it a little bit easier, right? If I want to see that extension data again, but see it in the command line live where I can interact with it, I can just run this, variable dot extension data, and I can look at my config, right? So I can say, what's the configuration of all of this? Here's all the config info that I have in that sub-property of the extension data. And really what I want to get down to is like the property for what was the date that this was created. So I can get down to this exact property to show like, hey, look, I built this thing on Thursday, and this was the time that it actually got stamped out on disk. So quick, simple intro to, how to look at things in PowerShell, how to understand how you can find commands that you can link together, and just how to investigate some simple properties. Okay, thanks. Okay, and we are back. Now we're going to take a look at some basic commands from Git. So what we're going to look at here is just the commands themselves before we look at the areas and kind of where things happen, right? So all of these commands on the left that we've got here, an add, a commit, and a push, are probably going to be the things that you're going to be using primarily when you're working on a local repository, and then eventually pushing things up. The things on the right are going to be where you're working with remote repositories, then your locals, and then your staging areas, right? If you don't understand these areas, don't worry about it. We'll get to it just a second in the next slide. But these 6 commands are probably what most everybody will use with Git, especially if you're not doing much other than working with a team to kind of check things into source control. If you're not doing, team development and things like that, this is going to be enough to cover you for most of it. If you really wanted to get into the nuts and bolts of it, I recommend everybody go get the Pro Git book. It's available for free as a download. It's an ebook in every format, right? Honestly, most people can go through the first 3 chapters or so of the Pro Git book, and that's about all they will ever need to know about Git. But let's go ahead and take a look at the flow, right? So here, starting at the top left, we're going to use a Git Add, right? This is going to be our working directory that we have on a file system. And this is going to take all of those, any individual file or all files that are in these working directories and put it in our staging area, right? Which means that this is something we're ready to actually, getting ready to commit, right? When we hit Git Commit, that's going to take all of our files that are in the staging area, and it's going to add them to our local repository, right? And we're going to give it a commit message that says, this is what I'm doing at this point. When we do a Git Push, this is going to be a command that's used to add all of our committed files that are in our local repository to the remote repository. This would be something like using, GitHub Online or GitLab if you're working inside of your lab environment, possibly. So in the remote repository, all files and changes will be visible to anybody else that has access to that remote repository, right? Anybody that's watching your repo on GitHub or things like that. With a git fetch, this is going to be a command that's used to pull things from our remote repository down to our local, right? So you get those checkpoints to your local repository, but you don't necessarily affect your working directory that's on your file system, right? This staging area and local repository is kind of an interesting interaction, especially if you actually watch the file system to see what's going on here. But again, git fetch just pulls from the remote repository to your local, but not all the way down to your working directory. If you want to pull from your local repository down to your working directory, you can use Git Merge, right? That's going to take what's your copy of your local repository and actually modify the files that are in your file system right then. If you want to do this all at once, especially if you're doing things like just refreshing everything that somebody else may have changed on a GitHub repo, you're going to use Git Pull. This is going to be a command that's used to get files from a remote repository and pull them all the way down directly into your working directory, right? It's going to be the equivalent of running a git fetch and a git merge, right? So that's all we need for Git to jump into the demos. All right, y'all. So first we're going to start off with a demo of Local Git, right? This is going to be us just interacting with the file system. It's going to be us interacting with the staging area and checking things into a local repository, not pushing anything, not getting anywhere off of our box, just pushing to the local repository. So the first thing we want to do is take a look at what we actually have in this directory here. So I'm going to run git child item. The only thing we have on the file system right now is this supersecretdata.md file. But I want to take a look at it so you guys can kind of get a little bit more of an interactive view of what's going on with this thing. So if we take a look at this inside of VS Code and I open up the file itself, it's aware of this, username, password, access keys, oh my, right? This is just going to be data that's living inside of this file that we don't want to check in. So we're going to figure out how to actually ignore this file and make sure it doesn't get checked into our repository. But I want to look at the GitHub view of this, right? Git is not aware of any check-ins for this, right? It doesn't have any initialization for it to believe that this is actually a repository it needs to be tracking. So first, we're going to do that. We're going to go ahead and run a Git Init on this directory. Okay. So we have initialized an empty repository in here. So first, the next thing we want to do is run a git status, and we can see we're on our main branch, there's no commits, and it's aware of one file that is not tracked. Just because I have coding on my command prompt here, I can see that I'm in the main branch and I'm basically one level ahead of what's here inside of Git for this single file that's untracked here, right? So we've looked at our status. Now what we want to do is go ahead and put a file in here. So we're going to go ahead and create a file, samplescript.ps1. We're going to just paste in the script that we had from our Power Cli demo and save this. So now when we just run another git child item, we're going to see we have these 2 files here, right? What we want to do is go ahead and add this samplescript.ps1 to Git so that it's now tracking this file. And if we run a git status again, we will see we're on the main branch. There's one change to be committed of a new file for samplescript.ps1, and we still have our untracked file of supersecretdata.md. Now, what we actually want to do is we want to create a git ignore file. So I'm going to do code and then .git ignore. We need the dot because it's supposed to be a hidden file here, right? And what we're going to do is we're going to add the specific name. You can do names, you can do file extensions and things like that, but we're going to add exactly the name of our supersecretdata.md file that we want to save in here. Now, if I run git status again, we will see that we now have, an untracked file of our git ignore, but we are no longer seeing our supersecretdata.md file. So we're going to go ahead and do git add all to add all of these files here and run another git status to say we now have our git ignore, we now have our sample ps1 script in here. And what we want to do is go ahead and run our git commit. So we're going to run our git commit of first commit, adding sample script. This is our actual commit message that got added here. First commit, add sample script. Now if we run a git status, we will see that we are clean, right? Nothing to commit, we're on our main branch, but the working tree matches what is in our local repository. So next we will take a look at working with a remote repository. Okay, for our next quick Git demo, we are going to be working with a remote repository. So we're going to start off with cloning down a repository that exists online already. We will go ahead and change into that directory from VMs to Kubernetes. So we will take a look at the Git log for this, and the last update we have in here is from April 30th for the Canada VMUG UserCon. So what we want to go ahead and do is we want to go ahead and open up the readme.md file, and we want to add a note in here to say hi from the 2021 Kansas City VMUG Virtual UserCon. So now that we've added this to our file, we're going to go do a git status again. And here we're going to see that we've modified this readme.md file, right? So we want to go ahead and add everything. So we're going to do a git add period. That's going to add the modified README file here into the staging area, right? So we're on our main directory. We now show we've got one modified file instead of one new file from our last demo inside of here. So if we run git status again, we're going to see that our branch is up to date with the original main, which is coming from the remote GitHub repo, and we've modified our readme.md file. So now we want to go ahead and do a commit a message with hello from the Kansas City 2021 VMUG Virtual UserCon. And if we run our git status again, we will see that we are now one file up, and we are ahead of the main branch by one commit here, right? So now if we want to push this to sync it up with the remote repository, we're going to do a git push. That will push this to our remote repository, in this instance, github.com/jhughes from VMs to Kubernetes that we cloned from in the first place. And now if we run a git status again, we will see that we are up to date because we have now pushed to that remote repository. Working tree is clean, and there's nothing to commit. Okay, for our final demo here on Git, we're going to be working with branches a little bit. Branching is going to be something we're going to want to do, especially if we're collaborating with many people on here. One of the things I advise people do is pretty much just kind of, create a branch that's individual to a user, so you can be responsible for your own code, and always have your working directories, pretty clean with what you're doing and not stomping over other people. Otherwise, if you're working on collaborative things on a tool or an application, this is where you may want to do things like have a branch that's for each individual release, right, or individual bug fixes that are getting merged back into the main branch instead of going straight to that branch all the time. So we're going to go ahead and change directories into this Terraform VMC demo. This is a demo for just working with Terraform for VMware Cloud on AWS. Now if we open this up in code, really what I want to see here is I want to kind of show everybody what we've got inside of this directory here. We're going to go ahead and show this as we are working on it. So I want to go ahead and take a look at Git branch, and we want to show all branches. So right now we can see that we're working on the main branch, right? But we actually have these other branches that are available here, right? This add NSXT rules, create SDDC, create VM. So as you can see here, we've got files that are, a 1_2_3_. This is the final version of this repository that's here. But if we actually want to go to Git checkout, we can actually see that we're up to current with our main branch, but we want to go back to this, say, create SDDC, which was step 1. So if we go to create SDDC and change into that branch, you can see the files here actually basically removed themselves, right? They're now hidden because this checkpoint that we were at with this on this branch only had these 1_ files. Now, if I do another checkout to get to my step 2, which was add NSXT rules, you'll see those files that were 2_ came back. Now, if I go to the kind of final step that I had, which was this create VM, which was step 3 in this repository, we get these hidden files back, right? These 3_. And now if I go to Git checkout just back to my main, then you'll see there's no changes, right? Because main is essentially, the checkpoint that I had that was at this third point of creating all of our VMs. But working on branches, you can actually have different things that exist in your working directory and your staging area and your local repository than what exists remotely, or different things that you might be working on. So if you're trying to, either hide things or work on specific focused stuff, this is a good place where branching might be a good thing to do, so you can, keep your code kind of in sync in individual little blobs at a time, just to be able to work with it a little bit more easily. All right, thanks, y'all. Okay, in this demo, we're going to take a quick look at Ansible. So starting off here, I'm going to be working on my control station. Essentially, this is just where I'm going to be running my Ansible playbooks from. To make sure that everything is functional, we're just going to go ahead and run a quick check. We're going to run the Ansible module of ping against this box itself. Just ping the loopback address of 127.0.0.1. So we can see that we've got success. This is just telling us Ansible was actually able to load. It was able to load in the module itself and was able to try and run a ping. So to have an idea of what it is we're going to be working against here, we're going to go ahead and run a cat against our Ansible Hosts file. So I just added a member group here. The rest of this is the default config file that comes with Ansible, sorry, the default host file. So what I did was I created a server group titled member, right? And I've got two servers in here, one by IP address, 192.168.10.161, and then I've got this other one with FQDN. So whether you're connecting via IP address or you're doing DNS resolution, right, you can do both, go back and forth. I've got some variables set here of just a user that's going to be used for Ansible connection, as well as the password for this. And then this Ansible become stuff is essentially sudo permissions for where it needs to be elevated. So just to show that I'm not hiding anything here, right, my Ansible test 1 box is this 192.168.10.161 box that's right here. So let's go ahead and clear the screen, and let's essentially run the same thing that we did earlier. Let's just do an Ansible load of the module again, but let's go against our member group this time. So this is just telling us that it's actually able to load in our inventory correctly, and that we are able to ping these boxes. So this looks good. We got a success against this box via FQDN and this one via IP address. So again, was able to load the module, no problems there. So let's do a cat of this wget check YAML file that I've got here. So this is just a playbook to see if wget exists on these boxes, right? Connecting to our hosts, the member group. We're using become, which essentially is elevating our privileges, gathering package facts, and basically I'm just running two different tasks. One wget installed, one wget missing. This is just determining if the name of the package exists in our Ansible_facts.packages information that comes back from the detail that we're gathering on this. So let's go ahead and run this playbook and see what we get. So this is going to check against these remote hosts, right? It gives us the name of our playbook, this playbook to check wget, gathering facts, which is going to happen every time Ansible is going to run. Then it's running our tasks for gathering package facts that we had up here. Then we are running through these tasks to see, is wget installed or missing. So since wget is not in the facts that we got back from the system, we skip the install, and we get back the output message that it's missing, right? This wget not found. So that shows us wget is not on these boxes. Let's clear the screen, and let's actually, let's go ahead and cat into our install real quick. So this is a playbook to install wget. Again, same information, connecting to that hosts group of titled members. We're using become for elevation, and we're just running apt install wget, right? We're using the apt module, we're giving it a name of the wget package and saying that the state should be present. So we'll go ahead and run this and see what we get. So we're going to run our install wget. Gives us the name of the playbook. It's gathering facts. Again, that's what Ansible's going to do every time we connect to a host. It's running our task for Ansible apt install wget, and we successfully changed both of these boxes. Right, we get this in the recap here that we have for the play. Okay against 2, changed for each line item. So all of these were fine, nothing unreachable, nothing skipped or anything like that. So now if we go back and run our wget check, we should have the task for wget is installed succeed for us. So yes, now we have wget installed, and we skipped wget missing because it's actually on that box. So everything looks good there. Okay, for our last quick demo here, if I take a look at the date on my control system, I can see that this is set properly for a machine that's AD joined, that I'm in the correct time zone. I'm on Mountain Daylight Time for being here in Denver. If I take a look at this test 1 box, this is still showing in UTC, and if I take a look at test 2, same thing as well, right? This is UTC time zone. So I'm going to cat our last playbook we're going to take a look at here, right, for just setting the time zone. So host group, again, member becomes true. This time I'm sending it a variable of time zone being a value of America/Denver, and I'm using the time zone module to feed it in that variable name, just to show, how we can have a little bit more flexibility with these things that we're doing. So if we run our Ansible playbook again and do set time zone, we will get our time zone set against these boxes. We're starting the playbook, gathering our facts, setting the time zone, updated and checked and set correctly against these boxes. So if we take a look again, we've now updated to MDT on both of these, and we've achieved success with this demo. All right, thanks y'all. So for our last quick demo of this session, we're going to take a look at Terraform here. We're starting off with our vars.tf file, which is just defining all of our variables that we have that are going to be used inside of this workflow. So just define all of our variables to say that there's a structure here for them. This terraform.tf vars file is where we're actually defining the variables that are going to be used when we run this this Terraform deployment. So using a local account on my vSphere box, right? So giving it a username and password, server we're going to connect to, things like our data center, cluster, data store, resource pool, network, the folder that we want our virtual machine to be in, what's the name of the template we're deploying from, and then what's the name of the actual VM that's going to come out the other side, along with the number of CPUs and memory that we have for it. Then we have our structure for this main.tf, right? This just says we're initiating a Terraform local backend just to show that it's here. We're not using Terraform Cloud for the state files for this or anything. Feeding in the variables for username, password, user, the vCenter server, all the vSphere details, data center, data store, cluster, pool, resources, networks and things like that. Then we get to the actual definition for the virtual machine itself, right? So giving it our name, telling it where we're going to go. That's going to come in either from the variables that we have in the other file or the data from all of the contents that have been instantiated earlier in here. And we're basically just coming through and cloning all of this out to stamp it out, give it a host name, give it a domain, and all of this stuff to the actual box. So to get started with this, let's go ahead and run a Terraform Init to get going. So Terraform will initialize the backend. It will go through and make sure that it's grabbed the vSphere provider plugin that it needed for this. And let's do a Terraform plan now. And we're going to go ahead and do an out file for this. So we're going to go ahead and give the file a plan.tf plan file name. So this shows us that it's, doesn't have this system in our vCenter server, so it's going to go through and create it, right? Gives us all of this information that comes through. A lot of this is stuff that comes in as defaults, right? Things we didn't necessarily even have to go through and set here, because some of this comes from the template that we're deploying from. So we've got all this in here in our Terraform plan. So now what we want to do is do a Terraform. So we're going to apply our plan.tf plan, which was the file that we saved our plan to. And we're going to see that we are now creating a VM. So if we click over to vCenter here, we'll see that we've actually got our VM populating into vSphere now. So it shows that it's up and running. Terraform shows that it's still creating, so we're waiting for this to finish here. So after 52 seconds, we've got a template that's actually deployed inside of our environment, and the host name that we deployed is this Terraform Ubuntu test. So again, just a quick run through to understand, variable files, the main TF, and a little bit of the structure for being able to deploy a simple vSphere VM to clone from a template inside of a vCenter environment. All right, thanks, y'all. So with that, I thank everybody for coming out. Sorry we had to kind of cut this short a little bit. Unfortunately, with the time restrictions, my demos and my rambling took everything way too long. So we are here at the end. Again, you can find these resources. As I have the free time to write up a blog post and hopefully record a couple of video demos on the Terraform and Ansible bits, I will put those up online. If anybody has any questions, if anybody has any feedback, if anybody thinks I did things poorly in here, please reach out to me either directly, via Twitter or joe@fullstackgeek.net. Otherwise, please present this back for the call for papers for VMUG next year, or I would be more than happy to have you in for a session for the Denver VMUG or for the Denver Powershell user group to come on and basically teach us all the things that I did incorrectly. Again, thanks for everybody coming out. I hope you all learned something, and I hope this helps you on your career journey.